In this lesson, you're going to be able to perform operations on functions, and you're going to be able to find the composite of two functions. First, for your warm-up. So I want you to pause the video, work these problems, then come back and check your answers. This one was easy. We just add the two together, so it's like combining the like terms. This one, use FOIL. And the final one, we're finding the difference between these two. Key concepts for function operations. If we're adding f and g, so f plus g of x is the same thing as f of x plus g of x. F times g of x is equal to f of x times g of x. F minus g of x is equal to f of x minus g of x. And f divided by g of x is equal to f of x divided by g of x, where g of x cannot be equal to 0. So let's let f of x equal negative 2x plus 6 and g of x equal 5x minus 7. We're to find f plus g of x and f minus g of x and their domains. For f plus g of x is the same thing as f of x plus g of x. So we substitute in f of x, negative 2x plus 6, plus g of x is 5x minus 7, and solve 3x minus 1. For f minus g of x, it's f of x minus g of x. We substitute in our expressions, and we've got negative 7x plus 13. The domain of f is the set of all real numbers. The domain of g is the set of all real numbers. The domain of f plus g and f minus g is the set of all numbers common to the domain of both f and g, which happens to be all real numbers. This time we're going to find f times g and f divided by g and their domains. So we substitute in x plus 1 in for f of x, and x to the fourth minus 1 for g of x. FOIL, and this is our answer, x to the 6th plus x to the 4th minus x squared minus 1. Now let's look at f divided by g of x. We substitute in our denominator. We can factor as x squared plus 1, x squared minus 1. The x squared minus 1 again factors to x plus 1, x minus 1. Notice these two factors cancel out, leaving us 1 over x plus 1, x minus 1. The domains of f and g are the set of real numbers, so the domain of f times g is also the set of real numbers. However, we cannot include negative 1 or positive 1 because it will make the denominator 0. So the domain of f divided by g does not include 1 and negative 1. Now for composite functions. The composition of function g with function f is written as g of f. Notice the open circle. And it is defined as g of f of x, where it equals g, and then in the center parentheses f of x, where the domain of g of f consists of the values in the domain of f such that f of a is in the domain of g. We always evaluate reading it right to left. We evaluate the inner function f of x first, and then use your answer as the input of the outer function. So we always start with the inner function. Let f of x equal x to the third and g of x equal x squared plus 7. Find g of f of 2. Now there are two different methods that we can use to find this. We rewrite the composite function, g of f of x. F of x is x to the third, so now we find g of x to the third. So we substitute x to the third in. So x to the 3 times 2 is x to the 6 plus 7. Then you substitute in a 2, finding g of f of 2. 2 to the 6 plus 7 is 71. Method 2, which is the method I tend to use most often, is substitute in the 2 in for x 2 it goes in for x, so it's 2 to the third, which would be 8, and then substitute 8 in for this x. So we take the output for this function, substitute it in as input for the next function. So since g is the outer function, we substitute the 8 in for x there, and we again get 71. So whichever method you feel most comfortable with, feel free to use it. Example 4. A store offers a 20% discount on all items, and you have a coupon worth $3. Use functions to model discounting an item by 20% and to model applying the coupon. Well, first of all, if an item is discounted 20%, then the original, what you're going to pay for it, is 80%. So let f of x represent the 80% cost of the material or whatever item you're buying. G of x is going to represent having a coupon, taking $3 away from whatever the original price would be. Use a composition of your two functions to model how much you would pay for an item if the clerk applies the discount first, then the coupon. So the discount is going to be inside and then the coupon on the outside. So applying the discount first, f of x. So we find g of f of x. And g is 80%, so then we substitute 8/10 x minus 3. Use a composition of your two functions to model how much you would pay for an item if the clerk applies the coupon first and then the discount. So it's going to be f of g of x. G of x is x minus 3, and f of x is 8/10 times x minus 3. So that would be applying the coupon first. How much more is any item if the clerk applies the coupon first? So we take our first one and we find the difference between our first one and our last one. Applying the coupon first or applying the discount first. And the difference is 60 cents more. Any item will cost 60 cents more if they apply the coupon first. Okay, time for you to begin practicing on your own.